Well, have you ever used sine, cosine, or tangent and suddenly got a negative answer, even though your math looked right? Don't worry, it's not a mistake. In this video, we are going to learn how trigonometric functions change in different parts of the Cartesian plane. By the end of this video, you will understand exactly when and why those signs flip. Let's make trigonometry less confusing and a lot more fun. Let's go. All right, so Cartesian plane. All right, now Cartesian plane is like this, right? This is 0 degrees, 90, 180 degrees, 270 degrees, and 360 degrees, right? Now, Cartesian plane has 4 quadrants. 1, 2, 3, and 4, right? I'm going to name them Q1, Q2, Q3, and Q4, right? Okay, now a Cartesian plane is made up of a vertical line and a horizontal line, all right? So this vertical line is made up of positive value of y and negative value of y, all right? And therefore, the horizontal line also is made up of the positive value of x and the negative value of x. What it simply means is these values here on that horizontal line are the positive value of x. All right, so it can be 1, 2, etc. Right, and therefore this side for the y values you will have positive 1, positive 2, etc. And this side on the y negative x values, what do you have? You have negative 1, negative 2, etc. And therefore, for the y, you have negative 1, negative 2, etc. All right, let's say you are given a Cartesian plane like this. This is your triangle, x, y, and r, okay? Look at this. This is in your first quadrant, okay? So this is quadrant number 1, okay? Now, the objective is to determine which of the trigonometric functions are positive or negative in quadrant number 1, okay? I'm going to go ahead and write my trig functions, which is sine theta, which is opposite over hypotenuse, okay? Cos theta, which is adjacent over hypotenuse. And the last one is tan theta, which is opposite over adjacent, okay? Now, when you look at the triangle that I have, right, sine theta will be y over r, okay? And then cos will be x over r, and therefore tan will be y over x, okay? So I've made a video about this. If you don't understand what I'm trying to say here, please go and watch it. I'll link it somewhere there. Now, remember, I want to determine which function is positive or negative in the first quadrant, right? Remember, y, right? This is y is positive. Remember that positive, negative. So this is y, which is positive. I'm going to say y is positive. Okay? And therefore, look at that. R is always positive. That is R, which is always positive. I'm going to put positive there. Okay? So this is positive. So positive over positive is always positive. Which means sign in the first quadrant is positive. Okay? I'm going to do a similar exercise on cos. All right. Now, look at this. X is on the positive axis, right? You remember, this one is positive axis, and this is negative. This is positive, and that is negative. So, in the first quadrant, x is positive. I'm going to go ahead and say x, which is positive. Okay? Now, remember r is always positive. I'm going to put positive for r. So same thing, positive over positive, which is positive. Okay? So it's similar like saying a positive value over a positive value, you'll get a positive value. All right. Now, the last one, what do we have? We have up and adjacent. Y, which is on the positive axis, right? Positive axis, and x. Look at x. X is also on the positive axis. So I'm going to put x plus here. Okay. Now, what does it mean? Positive over positive, which is positive. Okay. Now, the conclusion here is that all of them, right? All of these trigonometric functions are positive in the first quadrant. All right, let's say you are given a Cartesian plane with a triangle on the second quadrant. What do we know? X is negative, and then this is y and r, right? This is your angle. Now, this is in the quadrant number 2. All right, what do we know? Sine theta is opposite over hypotenuse. And when you reference our triangle, right, which one is opposite? This is opposite, is y, hypotenuse is r. So it's positive y over positive r. So it's positive over positive, which is positive. Okay? Now, second one, cos theta. Cos is adjacent over hypotenuse. Now, let's look at what we are given here. Adjacent is minus x. I'm going to put minus x for adjacent. And hypotenuse is always positive, which is positive r. Okay? Now, what do you have? You have minus over positive. Okay? So, minus over positive, the answer is negative. Okay? So, it's like a negative 1 over positive 1. The answer will be negative 1. Okay, now the last one, which is tan theta, which is opposite over adjacent. Okay, look at this. What do you have? Opposite is positive y. Okay, going to go ahead and put positive y, and adjacent is negative x. So this is positive divided by negative, which is negative. All right, now when you look at this, this is sine, which is the only one on the second quadrant, which is positive. Okay, so sine is the only one which is positive, and the rest is negative. Let's summarize. You are given that Cartesian plane, all right? What do we know from the previous slide? We know that this is Q1. Q1 meaning quadrant number 1, all right? All of the trig functions are positive, right? We've seen that. Now for Q2, we have seen that only sine is positive, okay? So sine is positive and all is positive. What about for Q3? We didn't get a chance to do Q3, but if you follow the same principle, you'll find out that only tan will be positive for Q3. And for Q4, quadrant number 4, you'll only find that cos is positive. Okay? This is how you can memorize. I'm going to put a C here. I'm going to put an A. So C for cos, A for all, and this is S for sine, and T, right? T for tan, right? Now, if you start from quadrant number 4 going this way, right? You can memorize. So you can use a mnemonic cast, right? So cast means C is positive on the 4th quadrant, A, all of them, all of the trig functions are positive on the first quadrant, S is positive on the second quadrant, and T on the third quadrant. Okay, let's put what we learned into practice. Let's say example number 1. Example number 1. If sine theta is equals to 3 over 5, right? And the angle is between 90 degrees and 270 degrees. Determine the value of cos theta tan squared theta. All right? The first thing when you're given an example like that or a question like that is you need to draw your Cartesian plane. Okay? This is my Cartesian plane, and this is my angle 0, 360 degrees, 90 degrees, 180 degrees, 270 degrees. Right. Remember that you are given the first condition, which is sine theta equals to 3 over 5. Okay? Now, what is sine theta? Sine theta is opposite over hypotenuse. Okay, meaning this is opposite. So this is opposite and this is hypotenuse. All right. Now, look at the whole number. So it's positive and positive, right? Which is positive, which means sine theta is positive, right? From the previous slides, you'd recall that we had what we know as C A S T, right? That was from the previous slide. Okay, what does it mean? It means that all of the trig or trigonometric functions are positive in the first quadrant, and in the second quadrant only sine is positive, and on the third quadrant only tan is positive, and on the fourth quadrant only cos is positive, right? Now we can establish from the first condition that we're given that sine is positive. But when you look at this, right, I'm going to put there the tick. So sine is positive on the first quadrant and is also positive on the second quadrant. Okay, now I need to move to the second condition. On the second condition, angle theta must be between 90 degrees and 270. So it must be on the second and the third quadrant, because this is 90 degrees and we are moving clockwise, anti-clockwise. All right, so we are moving anti-clockwise. So this is between 90 degrees and 270 is these two quadrants, right? What I'm going to do is I'm going to go ahead and put a tick on the second and the third quadrant. Okay, now you go back to your Cartesian plane. Now that you have represented these two conditions, you look at where you have two ticks. Okay, so on the second quadrant, that is where you have two ticks. What does it mean? That means that is where your triangle will be. All right, I'm going to remove that S there so that I can be able to draw my quadrant, my triangle. Now, my triangle will be on the second quadrant. Why? Because of these two ticks. All right. Now, let's go back to the first condition. What do we know? We know that 3 is opposite, which will be this side. So this is opposite and this is hypotenuse. All right? But we don't know what this is. Okay? We don't know the value of x this side. Right? Now, what I'm going to do is I'm going to remove this so that I can create space. Right? And use Pythagoras theorem to determine this value over here, right? Because this is a right-angled triangle. Now, Pythagoras theorem, right? So Pythagoras theorem says x, I'm going to remove that. So Pythagoras theorem, r squared x squared plus y squared. Y squared, what do we have? We have 5. This is y, this is x, and this is y, right? So r, what do we have? We have 5 squared. X, we don't know the value of x, but we know the value of y, which is 3. 3 squared. Okay, now x squared will be 16, right? And x will be plus minus, right? 4. Okay. Now, x is plus minus 4, right? But the final value of x, look at this. This is on the second quadrant, right? And its x must be a negative value because this is the positive value of the horizontal line and or the x-axis, and this side is the negative value, right? So that means the final value of x will be minus 4. Okay, so if the triangle was this side, right, x was gonna be a positive value of 4, right? Because it was gonna be on the positive x-axis. You get that? All right. Now we managed to determine the value of x. Okay, I'm going to remove x and put 4, minus 4. I'm going to put minus 4. So this is now known as minus 4. All right, great. Now let's go back to the question. We need to determine the value of cos and tan squared theta. Okay, let's go and do that. So cos theta tan theta squared. Okay, all right, what is cos? Go back to our triangle. Cos is adjacent over hypotenuse, which is minus 4 over 5. Okay, minus 4 over 5. That is cos. Now, tan is opposite over adjacent. Okay, so that will be 3 over minus 4 squared. All right, so you can punch this into your calculator or try to solve it step by step, which is going to be minus 4 over 5, and this side it will be 9 over 16. And then the answer will be minus 9 over 20. All right, in closing, let's say you have that Cartesian plane. I'm going to use the same example, all right, from the previous one. 5 minus 4 and positive 3. All right. What do you know? This is r, this is x, and this is y. Okay? So we know that when you have sine theta, that is opposite over hypotenuse, okay? From this as a reference, right? Opposite will be y, and therefore hypotenuse will be r, okay? Now, there's a concept called the reciprocal. What it means is the reciprocal of the trig functions, right? Or trigonometric functions. Now, a reciprocal for sine, right, is known as cosec theta. And cosec theta is simply 1 over sine theta. Okay? Now, look at this. What is sine? Sine is y over r. Now, cosec will be r over y. You just flip that fraction, right? So cosec will be r over y. Okay? And then what do we know? We know that cos theta is adjacent over hypotenuse. Okay? And then we know that it's x over r. And the reciprocal of cosec is sec. Okay? So it's sec theta, which is 1 over cos theta. What do? You look at what you have for cos and you just flip the fraction. So it's going to be r over x. R over x. Okay? Now the last part, which is tan theta, which is opposite over adjacent. So opposite is y over x. And then the reciprocal for tan theta, right? What do you have? The reciprocal for tan theta is cot. So it's cot theta, which is 1 over tan theta. Same thing, you just flip the fraction for tan theta, which is x over y. X over y. Okay? Now, let's say the question says determine cosec, and you're given that. The first thing that you do is you do that, and you just flip so that you can get this, right? And you continue like that. So r will be 5 and y will be 3. So this will be 5 over 3.